Hello, student. All of you welcome at Physics Point. I hope I hope your paper went well. Session one of JEE, right, my dear? Once again, student. Hello, everyone. All of you welcome at Physics Point. I hope your paper went well of JEE Session one. One important update, my dear everyone. From today onwards, I'm going to start preparation of JEE Session 2 come advance as well. Right, my dear? You can contact for individual tuition, fast compliance of syllabus for JEE main and advance at so there is a this is the following contact detail. You can see, you can take screenshot, you can contact here. Uh, According to your needs, if you want individual tuitions, fast compliance syllabus, I'll go through this beta. Now onwards, 11th class syllabus. Today I'll start. That is oscillation. It's one more important and highly, you can say, weighted topic for advance as well, my dear. Already I revealed contact of Registrar. You can contact over there. Hare Krishna student. Sir, should I study fluids for Saturday exam or was this lecture? No, no, students. Beta, you prepare the student yourself for Saturday exam. Beta, this lecture, my dear, only for 11th class student. Those who are going to be a part of JEE main sessions 2 and beta advance, right? So beta, you can go, my dear. Beta, you have to go and prepare yourself, student, for Saturday exam. It's a highly important, my dear. Right. So now, students, without wasting time yet, because Physics Point is a platform where here you can students learn and improve your skills in physics. Till now, if you have a fear in physics, because it's a very common by students, which I got, Hare Krishna student, Atharva, Bharadwaj. Oh my God, my pride. Yes. So students, today onwards, this is a lecture beta because physics point. That's why I started because someone also wanted student lecture on oscillations. So without wasting time, my dear, I'm going to start your topic of what I can say oscillation. Right, student? Okay. So beta, I can say in oscillation, what is the key point? Student, I'll go slowly, right? So that you can feel comfortable at this point, you can feel better comfortable at page one, my dear. So, students, in what's the chapter's name? Students, it's oscillation. What, my dear? It's oscillation. Okay. So, what's the topic of today class? Means I'll teach a student regularly. Student, every day I'll be live and I'll teach entire syllabus for I can say oscillation students. So watch me regular basis. This is the first lecture you can see for students oscillations, right? So before moving ahead, my dear, I wanted to uh, just discuss a few basics points for oscillations. So this is student first point. Uh, so what's the topic is which I'm going to start? Oscillation. Under oscillation, student, this is the basics points. So this is students, I can say periodic motion. What, my dear? This is what periodic motion. So, student, it's very simple. Student, it's very simple to discuss about periodic motion. Why, my dear? Periodic motion is what? A process. A process, students, or any motion which repeat itself after regular interval of time is called beta. Motion is called, you can say, simple harmonic motion beta, or you can say periodic motion. So again, I'm repeating, any motion which repeats itself after regular interval of time is called, my dear, periodic motion, or you can say harmonic motions. right, beta? So I'll write here once because this is a fundamental class of oscillation students. Any student, any motion. Student, just once confirmation my audio, video, beta both are clear. Those who are present. Okay, no one is present now. Okay, fine. Students, any motion, any, if anyone is present here in live stream, please just write in chat box. My audio, video, is it visible? Any problem? So please let me know. Any problem? Please let me know. With anyone? Okay. I hope so. There is no one. Okay, yes, you are Athar Bharadwaj. You are my dear. Okay, student, everything fine, student, like audio, video? If yes, beta, just please write in chat box. Okay, any motion, student, any motion, yes, it's fine. Okay, beta, God bless you, dear, for your reply. Students, any motion which repeats, students, any motion which repeats itself. Student, any motion which repeat itself after regular interval of time, my dear. After hello, Sagar Maharaj, hello, SR01, better you better, right? Yeah, Hare Krishna or Jai Sri Ram, whatever, but after regular students, after regular interval of time, after Hare Krishna SR01, uh, uh, but after regular interval of time is called periodic motion, my dear. It's called, students, periodic motion, or students, you can also say, or you can say, my dear, harmonic motion. Or beta, you can say harmonic motion. Beta, if you are liking session here, please like students video. Beta, your like beta literally appreciate for next candidate. Now, students, I wanted to discuss, my dear, that is time periods. So, okay, but students, first I wanted to give you a few example of periodic motion, right, my dear? Okay, let us suppose you can say, beta, this is what example, beta, of pendulum. What, my dear? Example of pendulum motion. No, 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 Sagar beta. This is beta only purely for 11th class student. Those who are going to write exam for JEE main beta ji or advance, right? Someone beta commented beta. You can go and check, my dear. Students, you can go and check, students. Someone commented, my dear, right? Someone beta ji commented on the, I can say in comment box. You know, everyone already I gave freedom for each and every candidate. Right, my dear? So someone commented due to, I can say, request of that student I started beta this topic beta ji. So student, you can take beta. What is the periodic motion, my dear? Uh, no, 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 SR01, not required, my dear. Beta, be prepare yourself, bacha ji. Beta,
For Saturday test, my dear. Pendulum motion.
pendulum motion. Right, beta? Okay. So you can take beta example of pendulum motion, beta. This is an example already I said. So let us suppose this is the I can say Bob beta at mean position, right, my dear? So now you can say if once you apply energy, what beta? Then you can say beta particle can perform this motion. So this is what beta? You can say beta this motion is what, my dear? Periodic motion, my dear. Aryan Visa, sir, when we are doing damped oscillation. Student, just now I started beta. It's a request beta. You can write it beta some request students in comment of beta. Someone Aryan beta requested beta ji. I can say like oscillation. So now today onwards beta, I'll go in smooth way. I'll start it beta for 11th 8 to 10 o'clock every day. I'll become on live. Beta for 12th class syllabus, I'll become you can say 12 to 2, right? Every day. So this is fixed beta the timetable. So you can take beta this example of periodic motion, or beta you can take beta another more example of periodic motion, my dear. Like you can say, bacha, this is sun, this is sun, beta ji, right? No, everyone. Earth is what, my dear, revolving around the sun. Due to this, beta, what we are just we are looking many changes like day to night, climatic change, and all. Right, my dear? So these are the things, bacha ji, which you can understand. If you are understood, beta, what is the periodic motion, bacha? Just like video and session, bacha. So your reaction. So these are, beta, I can say example of beta ji. You can see pendulum periodic motion, bacha, per day. Now, beta, just I wanted to discuss more basics one, beta, because this is students basics lecture. Now, beta, next time period. What student? This is time period. So, no, beta, I hope everyone know what's the time period. Let us suppose a particle started motion from here. Beta, particle, beta, you can say particle started motion from here, bacha party. So this is or beta, you can take most beta is example of sinusoidal wave. So this is students particle goes beta. This is what you can see time period. Particle, what is the time taking beta for one complete cycle? So this is what beta. This time beta, you can see this is t by 2 beta. This time you can see beta, this is what capital T only. Right, bacha ji? So you can say the constant interval student, the constant interval, constant interval of time after which, after after which the motion is repeated. What, my dear? The motion is repeated is called, my dear, this is time period. What is it? This is what known as dear? This is basically what I can say time period. This is what we tell you. You can say time period, my dear. Uh, Okay, Athar, beta, already I read a student. You can go and watch, beta, or you can take help of beta Suvir, right? Or beta on the channel, beta, there is a sequence, beta, already I mentioned, lecture 1, 2, 3, 4. If you want only numerical lectures, right? Then beta, you can go and watch beta that videos. Already beta, I uploaded on the Physics One channel. Yes, beta, you can go and beta just see. Now, bacha, you can say next bacha the oscillatory motion. What is the next point, beta? You can say this is oscillatory motion. Okay, the motion of a body. You know, beta, what is oscillatory motion here? You can take with the example, or I'll write it first definition. The student motion of a body is beta ji said to be oscillatory, said to be oscillatory, or beta you can say vibratory. What is to read? Oscillatory or vibratory motion, oscillatory or beta vibratory motion if it travels. What, my dear? If it travels, if it beta, you can say if it travels or beta moves, travels or moves back and forth. What bacha? This is beta. I can say major point. You can say bacha party back and beta ji forth, right? So our beta you can also say to and fro motion, to and fro motion about uh, about a beta g fixed point about a beta. This is the fixed point after what, my dear? Beta, this is the fundamental class. I'm covering basic point here because I'm getting beta in comment section. It's a tough topic. Literally, beta, it's a very easy bacha. Beta, a fixed point after certain interval of time. After beta what certain interval of time. Bacha, you can remember beta this point. Okay. Okay, fine. Okay. Uh, to and fro motion. Yes, 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 yes. So very good, beta. Sir, I'm very happy to see you, my dear. Sir, beta, I'm very happy to see, my dear. I can say Arnav Sharma. Okay, Arnav, you also join, my dear. Very good. Now, beta, you know what is oscillatory motion, bacha? But you can take example, beta. You can say this is a wall surface, right, beta? Okay, you can take beta example or any consideration of a spring block system. You can tell, my dear, sir, initially system is what? At rest, right? Okay, sir, Arab, not Arnab. Okay, Arab, got it, got it, Arab Sharma, Vidya. Yes, beta. Now, beta, I can say now, Bicha, let us suppose Beta, you wanted to pull this block towards right. Let us say you applied force on the block itself. Beta, due to application of force, what you can say, my dear? Let us suppose once, just take consideration. Beta, once you pull the block towards right and release. What is student? Once you student pull the block towards right and release, then beta what you can say particle student about mean position. What is student? Particle about mean position. Beta what performing SHM. What beta the particle is performing mean position. Beta this is what SHM. So beta I know there is one more important here. I can say bacha ji for this condition all oscillatory becomes periodic if there is what no loss of energy, if there is what no loss of energy, my dear. Okay, then beta I said mean position, so we can tell sir what is the mean position, what is the mean position. Either students, you can say mean position here or you can say equilibrium position. Beta, both are remain same. Students, either you can say, my dear, mean position, beta. Either you can say, my dear, this is what beta G. Either you can say this is beta G mean position or student, this is beta G this is what? Equilibrium position. Okay, fine, my dear. Okay. Uh, I can say Arab and Shah. You are present, both of you. Beta, you can take your contact of physics point with Saji. Beta, this is landline number, beta. This is only WhatsApp. You can ask directly any queries with Sir if you have, right, beta ji? Okay. Uh, I hope you taken beta. Arab and Shah. Now, beta ji. So, what is beta mean position here? The fixed point. Students, the student fixed point about which fixed point beta about which the body oscillates. What was the body oscillates is called what, my dear? It's a literally fundamental class here. Is called mean position, student. Is called student. This is what, my dear? Mean position, right? Or you can say it as a equilibrium position. equilibrium position, beta. Beta ji, both are remains same. Okay. Now what's the example as I said here? As I said, beta, what you can say example? Vibration of the wire of guitar here. Beta, what you can say, bacha party? Jai Shri Sam, my dear. Jai Shri Sam, beta. Okay. So beta, what is beta mean question? You can say bacha what? Vibration of the wire of beta what you can say? Guitar. Okay. Or beta you can say oscillation of mass suspended from what thing beta. You can also take beta. Already I see beta one example. Beta ji, this is also beta oscillatory motion beta ji, right? Or students you can take beta more example of this. Beta what you can say if any beta this is spring you can say student one end of a string remains beta fixed from beta here, or you can say beta ceiling, right? You can keep beta m is the mass of the block, right? So what you can say, let us suppose beta once again you want to pull the block in downward direction and release. Then beta what you can say, oscillatory motions are periodic motion if no energy loss during the process. Already I said. Beta, you know why beta I'm covering all the points because beta, what is the point they can ask? Hello, B65. You welcome, my dear, in the question there. So physics point is the platform. Here I'm just availing you. I can give it a to the point each and every point, sir. I'll not leave any weak point so that you can enjoy with the entire session here. Alright, what's about it? Now, which are just let's discuss next, my dear. This is harmonic. Beta ji, what you can say? Function. What student? This is student harmonic function. Okay, now you can say, sir, what is a harmonic function? You know, bacha, I can say, bacha, in trigonometry, what beta you can say, the trigonometry, this is what, my dear? The trigonometry function, the trigonometric function of student of constant amplitude of beta constant amplitude and student single frequency. What student you can say single frequency. Single frequency is defined is what, my dear, is defined as beta g harmonic function is defined as what, my dear? Harmonic function. Okay, beta, you can see as a beta example here, which I'll use randomly, beta ji. You can take by is equals to beta ji sine theta, or you can take, my dear, by is equals to a sine omega t. Beta, you can take both of these, beta. Both are remains same, my dear. Now, beta, I can say this is or the other beta because these two are beta. Mostly, I'll use beta in a harmonic function in simple harmonic motion, or you can see in the chapter of oscillation. This is what beta you can say. This is a cos beta, or you can write, my dear, this is y is equals to a cos omega t. What bacha ji? Y is equals to a cos omega t. Tan theta, cot theta, sec theta, and cosec theta are not a harmonic function. Students, Jai Shri Sam student, tan theta, cos theta beta. Again, I'm repeating tan theta, cot theta, sec theta, cosec theta are not what beta I can say harmonic function. Are not beta ji what I can say harmonic function. Right, bacha? So these are the beta I can say basic function which you can beta keep in your mind. Which you can beta ji keep in your mind, bacha ji. Okay, fine, beta. Have a look beta next. I can say beta some basic terms. Some basic terms beta. Already I said mean position, right? So you can say, sir, in basic terms, literally, student, literally it's very basic. Student, some basic terms. What, my dear? Some basic terms. So first, student, I wanted to discuss. Already I said. mean position. But here, student, I'll tell little different point of mean position, right? The point at which restoring force. What, my dear? The point, the point at which, because these are theories, so I don't want to leave any points. The point at which, student, the restoring force. What is, student? The restoring force on the particle. What is, student? On the particle is zero. This is a bit I can see beauty of this definition. What is, student? The point at which the restoring force on the particle is zero. And beta, this is a super point. Keep in mind, my dear. And potential energy. What, beta? Potential students energy is minimum. What, my dear? What are you hearing, all of you? This is what at mean position. It has been what you can say restoring force of particle is zero. Potential energy is student minimum. Potential energy is minimum is known as what, my dear? Is student known as its mean position. What beta is known as what beta mean position. What beta ji is known as what beta? Its mean position. Okay, Hare Krishna student. Hare Krishna student. Beta, please write your name. Maybe I can see someone commented about oscillation. I don't know what's the name of that. Why? So, because a request of that was student, I started a student like a chapter student, oscillation. Now, beta, because as I said here, no, this, which are discussing, my dear, each and every point interconnected to each other. Beta, you can say, hey, I said here, restoring force. Students, I said here, this is what, my dear, restoring force. So you can ask, sir, what is the restoring force? You can ask, my dear, what is the restoring force, right? So you can say, student, restoring force is what? The force acting on the particle which tends to bring the particle towards the mean position. That's all, bacha bati. You can understand restoring force also. Bacha ji, you can take example. You can take example, bacha, balloon, right? You can take example, bacha, for balloon, right? Beta, let us suppose I can say inside the balloon there is air filled, right? Because if you will apply force any surface anywhere on the balloon surface, then what it can absorb. Students, you can observe. So there is what beta after application of your force on the surface of balloon, that surface particularly beta, that surface student particularly what got affected after removal of force. What is mean, you can say particle come back in same initial state beta. So you can little you can connect but as I can say, restoring force is a kind of what? Principle of elasticity performing. Right, Vita? What is elasticity? Or I hope all of you remember. After removal of deforming force, particle attain its initial condition, shape, and size. So, what dear? That is what you can say elasticity, my dear. So, let's talk about student. This is next, Vita, some basic terms. This is second one, bacha, which is restoring force. What, my dear? Restoring force. Okay. Beta ji, for restoring force, the force acting on the particle, dear, the force acting, student, the force acting on the student particle which tends which tends to bring what, my dear, which tends to bring the particle Bring the particle towards its mean position, my dear. Towards, student, its mean position. What, my dear? Towards it mean position, right? Is known as student is known as student restoring force. What is student? Known as restoring force. Okay, fine, beta. This force always towards the mean position, beta. Note, student. What you can say, note, my dear. Beta, God bless you for your reaction. Literally, beta, if you're getting something at this point, please like video and show your reaction, beta. Your reactions and like help you, beta, next candidate, my dear. The note, beta, what you can write? The force, student, the force is always, force is always, this is students towards the mean position, towards the student mean position. This is what bit I can say restoring force. What is this? I'll tell you beta very soon. Beta, next point, beta. This is note number one, bacha ji. Beta, you can take snapshot, beta, right? SS bacha ji, I wanted to change the page. Okay, fine. बच्चा जी restoring force बेटा PDF notes available students for live class. Restoring force always acts in the directions of opposite to that the particle displacement. What student? Restoring force, student, restoring restoring force always, my dear, restoring force always acts in a direction opposite to what, student? In a direction opposite to that of what, my dear? That of particular displacement. That of, my dear, Subir beta, beta, my video clear bachcha and audio beta. If yes beta, just write in chat box beta. Yes beta, Subir, particle displacement, my dear. Particle displacement. Particle beta, what you can say? Displacement. Now beta, you can create student expression of what, my dear? Expression, student, expression of restoring force. Expression of beta, this is restoring force, right? Bachaji, F is equals to minus kx. What Bachaji? F is equals to minus kx, right, beta? In fact, beta, I can say you can also take a question like this. F is equals to minus kx to the power n, beta. This is the beta in reality general formula of beta oscillatory motion. Beta F is equals to minus kx to the power n, beta. This is the general formula, beta. What you can see for oscillatory motion, my dear. But student, for performing simple harmonic motion, beta G, student, here I'm considering, or already I considered, my dear, n is equals to 1. Due to beta, I can see it forever I'll use. Restoring force is what? F is equals to minus kx. What, my dear? F is equals to minus kx. Okay, because next point here, that is, students, I can say amplitude. What, my dear? I wanted to discuss amplitude. Student, I'll discuss first all basics point because physics point is the platform. Here you can enhance your knowledge from what which is the says 0 to hero. Yes, yes, beta. It's a true. It's a true. Physics point is a platform. Here you can enhance your subject knowledge you can build up your subject knowledge from zero to hero. That's why I'm not skipping any which point. I'm discussing each and every point, my dear, so that you can get benefit. You can share channel with your friends and family as well, my dear. Okay, fine. Now, students, I can say next is what? Amplitude, my dear. Right. So, what's amplitude, bacha party? Yes, really. If you are getting benefit at a physics one, bacha, you have to share my channel with your friends and family. Just spread me entire India so that entire India, beta, can get benefit of physics point, content, and methodology. Okay, beta, have a look, beta. I can say amplitude, right? The maximum displacement student, Hari Krishna student, the maximum student, the maximum the maximum displacement, maximum student, this is maximum displacement. Yes, beta, yes. Correct, beta. You wrote beta in chat box. F is equals to minus kx here. The maximum displacement of particle, student, the maximum displacement of particle, student, from mean position, my dear. Mean position. If someone joined newly, please go and watch beta previous video beta. I'll explain all the points. What's the mean position? What's the harmonic motion? What's the periodic motion? What's the oscillatory motion? How I wrote these all things. Beta, please go and watch there, right? Anyone beta, if you're feeling good at this one beta, please like video students. So your reaction beta, your reactions and like help you next candidate beta to get benefit at physics one content and methodology. Now, bacha, the maximum displacement of particle from mean position is defined as what, student? Is beta J is defined as, student, amplitude. Is beta z defined as what, beta? Amplitude, right, my dear? Okay, now beta, I wanted to discuss, I can say that is the last point, beta z, for basic concept, right? Beta, this is what I can say, beta, this is what, my dear? Simple harmonic motion. What is to read? Simple harmonic student. Simple harmonic motion. I wrote a student. Simple harmonic beta G motion. Simple harmonic motion. Bacha. In short, you can call it this is SHM. In short, student, you can call that is what, SHM. Okay. What is the SHM, beta G? What is the SHM? Beta, it is a special case of oscillatory motion in which acceleration is always. But what? Listen carefully. It is a special case of simple harmonic motion in which acceleration is always directed towards the mean position. Yes, beta. I'll write once here and also I explain by the diagram so that you can understand which is it. Now onwards, each and every point, literally it's marble point and superb important beta to kill the questions in the paper hall, my dear. What you can say as a definition, it is. What is good? It is what beta? Special. It is a beta. You can see of special case of beta oscillatory motion. It is a special case of beta. You can say oscillatory motion in which, student, in which acceleration is what, my dear? In which acceleration is always, in which acceleration is beta g always directed towards what, beta? Directed beta g, you can say, towards its mean position. Towards beta G, you can say towards mean position and is beta proportional to displacement and is beta. This is the marble point and is what, my dear? Proportional beta, proportional, proportional to displacement, proportional to beta displacement from mean position. Yes, beta ji. Now, yeah. Student, now I'm going to X beta. This is the definition here. One time, just you can know. Bacha ji. Now I'm going to explaining you with the help of diagram how you can understand. But listen carefully. But let us suppose, bacha. You can take constitution as an example. As what made it spring block system. Beta, you can take this is what example of fitness spring block system, right? So, student, this is one end of a spring beta, which is remains hinged, my dear. Okay, you can see to the wall, right, beta G. Okay, this is the block. This is what, my dear? Block. Sir, should be use multicolor pen. Beta, here not possible, but no, black color is better. It's very good. I can say for life system. Yes, beta. For if you are making notes with me, then student you have to use. It's compulsory, student. It's compulsory, student. I said multiple times in the classroom as well. It's a scientific reason. It's a scientific reason, student. If you have currently, if you are making notes with me, then use beta. It's a very good, my dear. Okay, beta ji, come to the point, my dear. Okay, let us suppose, students, you can say this is what beta ji. Initially, beta, you are what? Trying to pull. Beta, you are what? Trying to pull this block towards right. Right, beta? So you can take as a consideration. Uh, this is what? Block finally comes over here. Block what comes over here. Right. So you can tell, my dear, this is what beta ji. This is what known as, my dear. This is right. This is, student, right extreme position. This is what, my dear? Right extreme position. Right, beta? Okay. Just I'm taking consideration, beta. Just leave it. Listen carefully. Beta ji, you can say, sir, there is a displacement. You can take beta. There is a displacement. Is what? X. Is what, my dear? You can see there is a displacement is what remains x. Okay, beta, but what is the meaning of restoring force? If beta finally, if you pull the block towards right, but what's the tendency of beta? Restoring force always what towards the direction of restoring force towards the beta what towards the directions of mean position, right? So beta, I can say what there is what one force over there. So beta, we can say for this condition, beta, let us suppose particles is here, right? Extreme position. Beta for any cause. Beta particles, directions of restoring force beta. Always what? Direction of restoring force beta towards the mean position. So you can write it here. This is what beta is. Basically, you can say particle goes over here, but I'll do over there, bacha, right? So you can say, bacha, particle moved like this. This is the right extreme, and particle again come back over here at mean position. But bacha, this is beta points. You can take beta for consideration. Yes, beta. This is students. You can say left extreme position. Left. You can say what extreme position, beta ji. Okay, this is the right extreme, bacha. What I said, particles, beta ji, moves from here to here. Then, bacha, you can say particles definitely will go over there, right? And again come back beta. This is, you can see, simple harmonic motion. What is, student? You can say, my dear, this is what one complete oscillation of the particle. Particle beta moves from here to here. Then again beta come back at mean position. Then beta from mean position to what? Maximum displacement beta. What you can see with respect to left extreme position and particle again come back. What you can see, my dear? This is basically empty. Empty, it's not a Madhya Pradesh. It's not. It's what? Mean position, my dear. It's what, my dear? It's a mean position, bacha ji. Right? So now, beta, I'm going to reveal here one very interesting point. If anyone is present here, beta, just respond me in chat box. So this question already I explained in your class. No, beta, unfortunately, my dear, this question beta asked in JE 2026. In live session, beta, please respond me. Those I can say already earned this question from my side. I taught in class. I remember, my dear. What's the question here? Have a look. But this is what one sheet, one point beta. I want you to write over here. Acceleration beta. As I said in during definition of beta, acceleration is what? Always directed towards mean position and proportional to displacement. No beta. Particle motions toward right, but a displacement what beta? Towards left here. That's why I wrote beta A proportionals to minus x. A proportionals to minus x. Now, beta, I'm going to reveal those questions which already J asked in 2026. That's why I'm telling I'm covering all the points which will help you theory. Either beta I can say theory questions or beta I can say numerical here. Whatever. That's why just believe at this point. You will get everything what you wanted. Now, Bachaji, have a look here. What's the question asked by J? Beta, all of you know, this is what left extreme position, my dear. Right? Students, everyone know, this is what main position. This is student right extreme position. Just listen carefully here. Beta ji, you can say, let us suppose initially you release a particle from here. So what's the velocity? All of you agree zero? Just say me yes or no, beta. All of you agree zero, yeah? Yes or no? Tell me, everyone. This is students, you can say right extreme position. What student you can say already I said here, right extreme position. Okay, all of you agree here? Just tell me. Okay, Arav Sharma. Very good, beta. I'm proud on you, my dear. Okay, this is students left extreme position. This is students left extreme position. What's the question asked beta in JE? Subir beta, Subir beta, Rashid, anyone here present? Subir, Rashid, anyone? Beta, this question I taught beta in your class, right? Just respond me, bacha party. Beta, once you release the particle, beta, so, particle will what? Beta always move towards the mean positions, right? So here, students, you can say this is what students acceleration decreases. What, my dear? Acceleration decreases. Beta, see, this is what you can say, my dear. Beta, velocity of particle increases because you release from what? Zero, beta g. Okay. Now, bacha ji, have a look here next. But if you will cross mean position by body. So what's the acceleration over here? This is what acceleration of particle at mean position zero. Already I said, my dear, force is what zero at mean position and potential energy. Bacha party minimum here. I didn't. Yes, I never skipped any point here. I said restoring force beta. Somewhere I wrote here. Yes, this point. Restoring force on the particle is zero and potential energy is minimum. Is known as what? Mean position. So that's what I'm telling you. Stay here in the life session, you will get everything here. Okay. Now beta, A is what? Zero at the mean position, beta G. Okay. Beta, what you can say for further? Now, beta, if let's just cross the mean position bacha party, so what you can say? Now, beta, velocity started decreasing. And what beta? Acceleration started increasing. Right, my dear? Again, you can say for this point. What beta? A particle once arrived at beta extreme position left beta. Again, you can say velocity particle is what? Zero, my dear. Okay. After this beta, what you can say? A particle is moving from here to here. Right. Then, bacha, again you can say, sir, acceleration decreases and velocity, what, my dear? increases. Beta acceleration decreases. Beta g and velocity increases. Beta. Okay. After this student, what you can say again? Sir, A beta here again zero here. So here you can say, bacha, this is what here onwards, bacha. Acceleration will increase. And beta g, what you can say? Velocity will decrease. So, bacha, here again, here you can see for this condition, bacha, party will get what? Acceleration is maximum at extreme position. You will get beta what? Maximum acceleration at mean position, my dear. Right? Student, just remember one more point here. As I said, what's the amplitude? Student, this is the amplitude. Maximum displacement from Bachaji, mean positions to extreme position, my dear. You can say this is what, Bacha? It's basically amplitude. This is what, my dear? Amplitude. Okay, very nice. Bachaji, there is some observation here that those questions asking what J2026. What's the question here? I'll tell you. Student. Beta, take snapshot, my dear. Right. I want you to turn the page. Okay, beta. Have a look here. Next concept. Students at extreme position. Already I said. Student at extreme position. Beta, these all points I can see. You can write beta under note here. At extreme position. What, my dear? At extreme position, beta g, already I said velocity is what? Zero. So, and beta, these all points I'm covering, just I'm repeating because of numerical. These all points will help you to kill numerical quickly. Now, bacha, at mean position, what student? At mean position. Right, bacha? What you can write, acceleration is what? Zero. Or you can also say beta, force is what? Zero. But, what is you can say maximum? Velocity is what which I can say? Maximum. Beta, what you can say? Velocity is maximum. Okay. R. Sharma wrote something. Yes, sir. I can say correct. Okay. Maybe he wrote, I can say during some concept here. Okay, now beta, basic finished. Student basic finished. Now onward, students, I'm going to start. That is what, my dear, detail study. What student I'm going to start? This is detail. Beta, for I can see a detail study of any topic. You can go and watch all lectures already I uploaded. Relevant lecture, student. Go and watch, my dear. Detail study detailed study of my dear assets. Now, what I'll not repeat, I'll not write multiple times. Simple harmonic motion, bacha. I'll say simply this is what detailed study of simple harmonic motion, my dear. Okay, so we can say that what is this? Understand your situation, bacha, buddy. Let us suppose, students, here I'm considering you can take horizontal plane, right, my dear? Okay, students, this is the point. My dear, here I'm considering this is what, my dear? This is what? Basically, you can say it as a mean position. Already I said what is the mean position? Go and watch if you newly joined the channel of Physics One. Already I explained everything, my dear. This is mean position. But I say all of you know, sir, at mean position, velocity is what? Maximum. At mean position, velocity is what? Maximum. Let us suppose, beta, I can take consideration here because this is what? Extreme right, beta, and this is what, my dear? Extreme left. So, extreme right, student, this is what? I can say extreme right. This is right, beta. You can say this is what? Left extreme position. What, my dear? Left extreme. No, why I'm repeating beta this so that you can easily understand beta. There's no why I'm repeating multiple times same terms so that everything just during class just fix your mind. My intention बच्चा always your growth, always your growth. So that I'm repeating multiple times same statement so that you can understand everything in class only. If you are getting class, literally you are super. You are very good in study. That's why, because this is a live session, so I'm trying to control myself, go slow. Okay, beta. So what I said, velocity is maximum Bacha party. Let us suppose beta particle is what? At mean position, t is equals to 0. Right, Bacha party? At any time t dear, at any time t bacha, we can tell bacha ji. So this is what? There is some displacement beta. There is what, my dear? You can take some displacement, which is equals to beta, you can say x, which is equals to x. But you know, bacha, restoring force is what already I said, my dear. Restoring force direction always, my dear. This is what beta, basically restoring force. This is what, my dear, restoring force. Restoring force is what always towards the mean position, bacha party. Same thing, bacha. Let us suppose particle going in this direction. This is what you can write, my dear, velocity direction. This is what, my dear, velocity direction. But you know, mean position always. What, my dear? Mean position always towards beta g mean position. Mean position, bacha party always towards the mean position. Okay. Now, bacha, what is the oscillatory equation for force? Already I said, my dear, F is equals to minus kx. F is equals to beta g, what can I say? This is what minus kx. Now onwards, beta g, how you are intelligent in mathematics. Here will reflect it, because now onwards I'll discuss only maths. I'll discuss only maths. So if you are good in maths, then you will enjoy entire session. Otherwise, if you're not good, then listen me carefully. Yes, beta. Now, beta, what I can say, force is equals to F is equals to minus Kx. This is what oscillatory equations, Bachaji. I wanted to find beta. There I know there are six relation here in, I can say, beta, in kinematics. Now onwards, beta, I'll repeat kinematics like AX relation, VX relation, AT relation, VT relation. You can say, bacha, like beta, there are many ways here. There are beta basically six relation, right? AV relation and all. So I'll discuss one by one, my dear. Right. So beta, what is the force? We got F is equals to minus kx. So beta, I wanted to write expression of acceleration here. So what is the acceleration, beta g? A is equals to force per unit mass. What is, student? A is equals to force per unit mass. Okay. बच्चा जी, here yeah something I'll beta just change बच्चा party. Okay, so what is force बच्चा? Force is what? Minus kx beta g. So I wanted to just turn the page here, right, my dear? Okay, so beta, you know, acceleration I can write a is equals to minus k upon m into x. What is k upon m, bacha? I'll tell later, my dear. Right? So a is what, beta? Minus k upon m into x. So beta, here, let us suppose there is beta conditions here, which I'll prove later. Beta, now you can say omega square is nothing but this is what, my dear? Omega square is equals to k upon m. So omega I can write, my dear, this is basically k upon m. Beta, what you can say, this is what k upon m. Omega, what student? You can say, my dear, this is angular frequency. This is, you can say, bacha, angular frequency beta g. Okay, so this is what acceleration bacha party. Now, student, I am going to use your one things. Beta, some supportive mass part beta I'll do here so that you can understand bacha the force per unit mass. Beta, correct beta. God bless you, my dear, for your response in chat box. Now, bacha ji, in the classroom, student, already I see it multiple times. In fact, if I was I can say I was live during making live discussion of JMIN 2026. Already I see this point there as well. But what I can say. This is what if beta you can say a as a function of t, my dear. So you can write a is equals to beta what dv by dt. Student, if a as a function of x beta, students, if a as a function of x, students, you can write a is equals to v dv by dx beta. What is student v dv by dx beta g? Okay, so beta I know this is a as a function of x. What my dear, a as a function of x. So student, I'll replace acceleration is equals to v dv by dx beta g. Acceleration beta I can write v dv by dx, which is equals to what my dear? K upon m into x. Okay, fine. Beta just you can apply beta concept of variable separable. What students? Students applying concept of variable separable. What beta G? Variable separable. Right, beta? So what does it mean here? Beta, you can keep together, beta. Same variable, right? So, beta, I'll take here x one side, beta, and velocity terms one side, my dear. So, v dv, which is equals to minus k upon m into x dx into beta the x dx. Beta, God bless you for reaction, beta the. If you are really liking video, if you really liking please find live session, beta, please spread me with your friends and family, dear. Will maximum can get benefit because of your help, your efforts. So now just do beta magic of your finger, beta. Just improving the physics point, spreading physics point pan India, beta. Do magic by your finger. Okay, bacha. So this is beta what you can say video, bacha party. Now, beta, just we'll go through this here. Beta, what I can say, how can we take your limit? Beta, for taking limit here, beta, I'll make once diagram again, bacha party. Or beta, I can use bacha. If time zero, beta, what's the velocity maximum? If time beta, t beta, what we can say velocity? Bacha ji, this is what? Zero only. Right, beta? So let us suppose here, students, I'm considering over here. This is what? Beta ji, this is what? If velocity is what? Zero. Beta, what we can say? Velocity is zero, bacha party. So beta, what you can write over here? What's the beta maximum amplitude of the particle? This is A only, right, beta? If beta, you can say, beta, this is what? Distance traveled by particle is x. So what's the velocity of the particle? This is v. Okay, beta. Again, I'm repeating, my dear. Bacha ji, if beta velocity is zero, so particle beta what we can say? Beta that is what? A only amplitude bacha party. If beta x, then beta what you can say? This is what? Basically velocity beta v only. Just beta integrate both sides here. So you can see bacha this is what? X to the power n into ds beta what you can write? X to the power n plus 1 upon n plus 1 plus c bacha. Beta this is for indefinite, but this is what, my dear? Definite integration. So what I can write over here, bacha party. This is v square by 2, which is equal to beta minus k upon m. What which I can say upper limit is what beta? Or I'll write here, not be much hurry, bacha. X square by 2. This is not a physical class here, so you can answer how this is. I'll go slowly, bacha. Now beta you can say these two cancel beta. I hope you got it. V square beta I can say minus k upon m bacha ji. This is beta. I can apply limit upper limit minus lower limit, my dear. So this is x square minus beta the a square. Beta you can take minus inside here, or you can take beta minus outside. Both applicable. You can write beta v square is nothing but this is k upon m into beta g a square minus beta g x square. A square beta what you can say minus x square beta. God bless you for your reaction, my dear. Okay, so bacha ji, finally we'll get result bacha. What v as a function of x beta g, right? So bacha here yeah, you can write v is equals to beta what we can say this is what bacha ji, this is beta root of k upon m into beta g a squared minus x squared to the power 1 by 2. This is beta what you can say here. This is beta what we can say omega. So we can write beta as also here. Just rewrite beta same equation, my dear. So rewrite beta same equations, my dear. V is equals to students omega. Beta, God bless you for reaction, student. A square minus x square to the power 1 by 2. But I know this is what beta we got here. Finally, bacha ji, v as a function of x. What bacha ji? V as a function of x. Beta, one thing I forgot is so I wanted to cover here. Right? Beta, what I said. This is the force per unit mass bacha party. Right? So bacha, you can say acceleration here. What is I wrote acceleration? That is on next paper. Beta, I can say acceleration I wrote beta. This is what? Minus k upon m into x. Acceleration message minus k upon m into x, right? Beta, G asked here. Student J already asked. Okay. Uh, beta, what's J asked me, buddy? You have to draw beta. You have to draw diagram A versus X. Beta J, draw graph. What bacha? A as a function of X. Or you can say beta A versus X here. Bacha, God bless you for reaction, my dear. Okay, so simply you can say, bacha, this is what A is proportional to X. But beta, what you can say, slope is negative, bacha ji, right? You can compare, bacha ji. A is equals to minus K upon M into X plus 0, beta. You can, beta, on what by axis, you can take, beta, this is A. Beta, on X axis, you can take, beta, the X, right? So you can write, bacha ji, y is equals to this is mx plus c, bacha. So what's the slope, my dear? Slope is nothing here. This is k upon m. Which is what? Negative, bacha party. And intercept is what, bacha party? 0. So what is the graph beta which you can draw? What is the graph beta which you can draw? A versus x there. So this is the graph beta you can draw, student. A as a function of x. What is student? A as a function of x. Hare Krishna, student. Yes, beta. E as a function of x. So, beta, this is the point here, which beta you can keep in your mind. E as a function of x graph, right? Now, beta, I wanted to draw beta. I finished watching all your lecture. Okay, very good, beta. I'm proud on you, my dear. Okay, then beta, I can say, are you Sibir? Are you Subir or someone else? Uh, hmm, who is? Beta, write your name. Then beta, I'll guide you more, bacha. Write your name, my dear. I'll guide you more, bacha. Now, should I solve a module, sir? Yes, beta, you can do. You can do, my dear. You can do, my dear. You can do, my dear. Yes, beta, you can go ahead, bacha. Okay. But what we got, beta, finally? V as a function of x. Aditya Krishna. Oh, my pride, my Krishna. Happy to see, my dear. V as a function of s, beta. What? V is equals to omega a square minus x square to the power what, beta? A by 2. Yes, beta. Regular visit, beta. This one, beta, Aditya Krishna. Lecture concern, beta. Already uploaded, beta. Beta, God bless you, my dear. V as a function of x, beta. Now I wanted to draw, beta, graph V as a function of x. What, my dear? V as a function of x. Okay, beta. Just I want to turn the page, beta. Ji, just beta, take snapshot, my dear. Right? Okay, beta. Beta ji, I can say for further update here. What we got is for further calculations, my dear, not update. V beta, I already calculated. We already got. V is what? A square minus x square. V beta what? A square minus x square. Beta, do a squaring. Squaring both side, my dear. Student, do squaring. Beta J, both sides. Yes, beta. Squaring beta both sides. Beta, God bless you. You are literally active here. Beta, can you write your name, beta? Your name, beta, just Devi. Can you write your name, beta? You are also regularly watching, beta, my channel here. Since I can see last 1 hour approx. Beta, can you write your name, beta, so that I can call you, beta, by your name? Beta, squaring both sides, beta, buddy. What you can, beta? V square is equals to omega square, my dear. This is a square minus x square. Beta, just beta, keep this idea. What you can say, v square upon omega square plus beta g x square is equals to beta a square. Beta, just divide both side here by a square. My dear, you can see bacha, v square upon omega square a square plus beta ji what? X square a square is equals to 1. I hope anyone is present of my class here. Anyone present here of I can say class which I can say I taught you already beta this thing here. This is what my dear look like what equation of ellipse x square upon a square plus beta g by a square upon b square is equals to 1. X square upon a square beta plus by a square upon b square is equals to 1. So beta you need to draw here v as a function of x. No student, I'm not skipping any beat point. Beta here discussing each and every point. So if you got delay to join physics point, go and watch. Right, beta? So this is what beta I can see v as a function of x. Beta, what I can see v as a function of x, my dear. Okay, then beta already we got here v as a function of x, beta. So beta, we wish to find here x relation. Beta, we wish to find what x relation. Beta, for further calculation, beta, I'll use same result beta, which already we calculated. So V is what beta? Omega. Beta, you can see this is what? A squared minus x squared to the power beta g 1 by 2. V beta from kinematics, sir. I hope all of you know this basic point, beta. Beta, I can write here. V is what beta? V can write, my dear. This is dx by dt. V beta, what you can write? This is dx by dt. Okay, beta. I'll use beta this concept over here, beta. Now, beta, I'm going to replace v is what, beta? Dx by dt, which is nothing but omega squared. Beta, God bless you for reaction, my dear. This is a squared minus x squared to the power 1 by 2. Beta, again here, I'm going to apply concept of variable separable. What, my dear? I'm going to apply concept of variable separable. Beta, I'll keep beta x together and remaining beta, I can see t terms. Beta, just separate beta these two terms. This is the meaning of what? This is the meaning of concept of variable separable, my dear. You can say this is what? Dx upon beta a squared minus x squared. Beta, this is what? Under root, which is equals to beta, I can write omega into dt. This is what, my dear, omega into dt, beta ji. Okay. Here, beta, again, here, we can apply the limit, beta, as usual. But I know, beta, I wanted to tell you this formula. I wanted to tell, my dear, this is the formula, beta. What's this formula here? Beta, you will learn, beta, this formula, I can say in 12th class, beta, integration, beta. But meanwhile, I'm beta giving the formula here. So this is what, my dear? This is a square minus x square. It's nothing but beta. This is sine inverse beta g x upon a. This is what, my dear? Sine inverse x upon a. So beta, student, I'll use beta this result here, beta only. This is beta limit. You can see if time is zero, there is no displacement at all, as you know everyone beta. Okay, now students, you can see if time becomes t beta, so what's the displacement here? You can take beta x. You can take beta x. Now, bacha ji, what's the integration bacha party of this terms here? You can beta use direct result from here, my dear. This is sine inverse x upon a. Beta, what you can say? Sine inverse x upon a. Limit beta is what? 0 to x, which is equals to which I can say omega into t are simple, dt beta t only. All of you know here, dt integration is t. Integration of dy is y. Integration of dz is z. Beta integration of dx is beta x only. Right. Now, beta, you can say this beta apply limit beta simply here. So initially beta x, so there is no change at all, my dear. You can say sine inverse. What beta ji? This is x upon a. Upper limit minus lower limit beta. Right. So you can say beta this is what? Sine inverse of 0 is equals to omega t. It's nothing but it's 0 beta. Beta what you can say this is what remains 0 beta party. Now beta what you can say Beta, you can write like that here. X upon A is equals to what, my dear? Sine omega t. Simple, beta. Okay. X you will get, bacha. X is what function of time t, my dear. X you got, beta, as a function of time t, bacha. A, this is what, bacha, the sine omega t, right? So here, beta, you need to find, you need to draw, beta, draw a graph, student. I'm not skipping any point, bacha party, right? That's why it's a little linear, but you can watch anywhere because this is the live session for, I can say, worldwide for all category of student, like bottom to top. Anyone can watch. Now, bacha, this is what draw, beta. Draw graph, students. You can say draw graph of XC. What, bacha? Draw graph what XC relation. So what? I hope all of you know your sinusoidal function. I hope it all of you know bacha sinusoidal function graph. Otherwise, remember now onwards. Because this is, my dear, you can say xt relation. Sine function beta always starting from what beta you can say? Start beta can take initial point from origin bacha party. So this is what you can say bacha x as a function of t, my dear. You can take there. This is what you can tell x as a function of t bacha. X is what a sine omega t bacha party. This is beta you can say which I wrote bacha party. X is equals to sine x is equals to beta a sine omega t. Students, which I wrote x is equals to beta x is equals to a sine omega t. So here I'm not considering initial phase, right? So beta, this is known as the general equation of SHM. Now onwards, beta, you can keep in your mind general. This is what x is equals to a sine omega t. General equation of beta. This is what SM. Here, beta, I didn't consider beta what I can say initial phase and all. Right, beta? Initial phase is what, beta? For this condition is what I have taken 0, my dear. Okay, fine. After beta, you can say we have a XT relation. What, my dear? We have a XT relation. Now, beta, we wish to find what is the VT relation. What, beta? What is the VT relation? Beta, for getting VT relation here. Beta ji, for getting beta velocity time relation, student, I'll use xt relation, right? So what's the beta xt relation? X is equals to a sine omega t. I hope all of you remember if we have x as a function of time t, if we will differentiate one time with respect to time, bacha, then what you will get? Velocity, or you can see speed of particle, right, beta? But here I'm looking at velocity of particle. Bachaji, then what you can say? So this is V is equals to, you can see d beta dx by dt. X bachaji already here. We know, but I can fit beta this value over here. Bacha. So V is what, my dear? Differentiation of beta a sine omega t upon dt bacha party. So beta, this is I hope all of you remember. Otherwise, I'm writing it. It's a chain rule, right, beta? This is what differentiation of beta. Just a leave it, beta. Beta here, beta. I'm just differentiating beta sine omega t upon dt. It's very simple, beta. First, beta, you have to do integration of primary function. Sir, it's Bacha, first beta, no, what is the same rule? Beta, you have to do first the primary function differentiation. Student, you have to first do beta what primary function differentiation. So who is the primary function? Beta, the sine is the primary function. So beta, you have to do beta sine differentiation. I hope all of you remember sine differentiation is cos. So you can write beta cos as it is cos omega t. Now, bacha, we can do beta integration of secondary function. Student, sorry, my bad, beta. You have to do beta. First, you have to do differentiation of primary function. You can beta write as it is. Sine is what? Cos omega t. Now onwards, beta, you have to differentiate again, bacha. differentiation of beta. I'm writing here one time because I'll use beta further. Differentiation of omega t upon dt. Beta, what will get? This is omega. Beta, this omega beta you can apply. Beta, simply you can multiply. That's all, Bachcha party. Again, I'm repeating it because I use beta multiple times. What is the chain rule? That's the differentiation of sin omega t. First, you have to do differentiation of sin beta, which is equals to cos. Entire function beta, you have to write as it is. Then, student, you have to do again here. Differentiation of beta is secondary function. So, differentiation of omega t beta. What you will get? This is what? Omega. So, finally, beta will get here sin omega t is what? Omega sine cos omega t. Omega beta what? Cos omega t. Students, here I'll use beta as it is here. So you know beta, A is a constant here. So beta A will come out. Omega beta, again beta constant, so beta will come out here. And sine is what beta? You can say this is cos omega t. Finally, beta, we got result for what? V as a function of t. What beta? The V as a function of t. Okay, correct beta. God bless you, bacha. Very good beta. I'm very happy to see beta your response in chat box beta. Very few people beta active now. I can see in live session, but still you are the first one. Now, bacha, V as a function of sine t beta. So V is what? A omega cos omega t. Now, student, you have to draw. Student, you have to draw graph graph of beta, you can say VT relation. What is student? VT relation, my dear. No, bacha. This is what? Cos function. So cos function beta always graph beta what? Initial point of cos function bacha. This is what? Beta plus one only. So this is what, my dear, you can say graph beta of cos x. Beta what you can see? This is beta what? Graph of beta you can say VT relation here. So VT is what beta? We can say cosine function bacha party. So you can say graph what? Beta cosine is starting from plus one bacha. And this is what? You can say bacha party minus one bacha. This is the beta. So you can say like beta t by 4 and everything bacha party. Okay. Now beta we got your VT relation. Beta we wish to find next year. Yes beta. Yes. Correct. Very good beta. Can you write your name bacha? That's 19 efforts. Very good your response, Bacha. I'm very happy to see beta your response in chat box, beta, in live session. Appreciable, Bacha. Beta, take snapshot, my dear. I wanted to turn the page. Okay, fine, my dear. Bacha, now I wanted to find bacha AT relation, right? So beta, to just beta get answer of AT relation, bacha, I'll use my dear VT relation, right? Okay, so beta, now I wanted to find beta. This is you can say this is what beta? This is acceleration beta G. This is time relation beta. Acceleration time relation beta party. We just now got here. V as a function of t. What beta? A omega cos omega t beta. But I hope you are again no, as I said, now you are just I'm revising kinematics, my dear. If you have a v as a function of time t, so you can still, sir, acceleration we can get what one time differentiation. So what beta? We wish to find acceleration here as usual beta. So we have to differentiate students one time. So now beta for acceleration beta, what you can see? This is dv by dt beta. We already mentioned students. You can use directly, my dear. So this is a bacha party. Bacha, I'm teaching my dear. This is oscillation, bacha. Beta like Divya, you requested a student for I can say bacha ji current electricity. Someone beta requested beta in comment section. They wanted beta chapter of oscillation. So you know beta, I can say student. J means beta session one finished. So I decided bacha do the chapters honestly one by one beta, right? So Divya, beta, I wanted to just inform one thing, student. This is beta, I can say, beta, this is beta, I can say message for all candidate who want to take a student like individual class to fast compliance of syllabus student, right? Everything. Then beta, already I started 11th class syllabus, bacha. So beta, you can beta contact anytime. You can beta. This is the landline number of Physics Point. But WhatsApp you can do over here, or you can also beta post your queries in what I can say beta in comment section bacha party. Okay, I hope all of you taken beta screenshot. Now bacha, I can see dv by dt bacha. So d bacha party and v beta we already got. This is what is students? A omega cos omega t beta g. Beta, this is what my dear? D A omega cos omega t. Now, student, again I'm explaining here what is the chain rule, right? Beta ji, what is chain rule here? No, bacha. A beta, you can take it out. A omega beta, it's constant beta. So, students, you can write beta as usual. Beta, there is no change. So, this is what differentiation of beta cos omega t upon dt. Beta, as I said previously as well, beta ji, right? So you can beta write once more here. This is student cos omega t. I hope beta you are in 12th class Divya beta, but still I'm repeating here. Beta, what is the chain rule? Student, you have to do first primary function differentiation. So beta cos is a primary function, my dear. Right? So beta you can write this is what beta minus. I hope all of you remember cos differentiation is a minus beta sine theta. So you can write beta as it is here. Sine beta the omega t. Beta what? Now, what is the secondary function, my dear? This is what? Omega t beta. So do differentiation of beta omega t. You will get beta what? This is the omega. So simply, bacha, you can write as an answer for differentiation of cos omega t upon dt minus omega. This is what, my dear? Sine omega t. Minus omega, beta what? You can say sine omega t, my dear. Okay, बच्चा जी, yes, Arab beta, yes beta, Arab, do board beta first. Beta Arab 11th class beta, I'll start beta. I can say in the month of last week of February beta, you can beta just finish your beta paper of 10th class, then you can join beta physics one. Beta after that beta, after your paper student, you can explore physics one beta party. Here is the platform. You can see also, yeah, no one teaching on YouTube. What I'm teaching here, all of you know, all of you visiting here regularly, I can see everywhere, bacha party. Hello, woman beta. How are you, my dear? No, beta. How I'm just putting stress to just explaining the things, bacha. All of you visiting YouTube channel everywhere, yeah. Just you can write beta in chat box or in comment section anywhere under the video. How I'm explaining the student. You can just compare my explanation here from another institute or another YouTube beta channel. Right, bacha ji? Beta, I'll use bacha differentiation of cos omega t minus omega sin omega t, bacha, as it is, bacha. Party over here, beta. Very, beta, God bless you, beta, for your, beta, I can say, beta, appreciation, beta. Yes, beta. Now, beta, A, you can write, my dear, this is minus A, bacha ji, omega. What, bacha, you can say, this is omega, student. This is, no, beta, I'm trying here, just connect each and every students of Pan India. That's why, beta, I decided here, beta, I can say, to just start live class so that, okay, fine, fine. I got it, my dear. I got it, Chazi. They are 8th class watching this video. Very good. Very good, beta. I'm proud of beta, Arvind, to see you. Beta, I can see lives in Bacha Party. Okay, beta, I can write here acceleration, my dear. A is equals to minus A omega square, Bachaji sine omega t. Beta, this is what? Acceleration here. Beta, what? Minus A omega square sin omega t. Here, students, again, same thing, bacha. Beta, means, I can say, beta, what's the questions? Beta, as example, you can say, this is draw, draw, beta, the acceleration time graph. Draw beta what? Acceleration time graph. Now, bacha, everyone know here what's the sine function? Always what started from origin. But beta, God bless you, dear, for your reaction here. Yes, beta, really you are liking beta. I can see Woman, Arvind, Bhavya, Arab, and many students those present over here. Please, beta, share my channel with your friends and family. Beta, show your reaction, bacha. Your reaction, one share, one subscribe, one like help a lot beta for next candidate. It's a true beta. It's a true, my dear. So beta, you're enthusiastic beta. Everyone in the class literally liking beta. Please show your reaction, my dear. Okay, now beta, I'm going to draw beta 80 relation. So this is what student you can say this is what 80 relation bacha party, right? But you know beta, this is sign is negative beta. You can draw beta graph from what? Beta, I can say downward direction bacha. So this is what beta I can say 80 result. This is what my dear 80 result. Beta, I wanted to find one more graph here. So this is beta, just keep in your mind bacha. This is what 80 result and acceleration time beta relation be found. So literally our chain rule beta. I put says a lot beta to explaining what I can say chain rule. If go and watch the detailed video anywhere, anytime or beta entire things. Beta God bless you Arvind Bacha for your appreciation, my dear. Okay, beta. Now, beta, I wanted to find AV relation. What, my dear? I wanted to find AV relation. Bacha, take snapshot, my dear. I wanted to turn the page, my dear. Okay, bacha ji, beta, bless you. Stay happy, my Arvind. Okay, my prize. Yes, beta. Now, beta, I'm going to find bacha. This is what students acceleration. Bacha ji, acceleration velocity relation, beta. Acceleration velocity uh, relation, बच्चा जी. Okay. Now, बच्चा. I can say, woman, my dear, just beta basics finished. Real started beta, I can say last 1 hour beta. So beta class already beta, sir, I feel very helpful. Beta, God bless you dear for your appreciation. So woman bacha, you can beta go and watch. Beta, I'll upload as it is same lecture on YouTube bacha. Right? So you can feel comfortable, sir. Call my name. So you can comfortable bacha. You can learn the topic bacha. So, beta, basic finish there. Real beta started just now. I can say beta last 30 minutes, bacha. Right, my dear woman? Okay, beta, we continue. Now, bacha, already we got here. We wish to find what? Acceleration velocity relation. Okay, I hope you got it, woman. Now, bacha, so beta, we got here. What is the beta? What is the acceleration, bacha, party? A is equals to minus a omega square. What bacha is sine omega t. Beta, just I'm just going to adjust here a little bit, Sakati. So A, beta, this is what? Acceleration upon A, omega square is what? Minus student sine omega t. Beta, I'm calling equation number one. Beta, I'm calling equation number one. Yes, beta. Yes, beta. Woman, good, beta. Now, beta, I'm going to use bacha party. VT relation here. Beta, what I can say, this is what bacha party? This is what, beta, I can say VT relation, bacha. Okay, so beta, what is VT relation, bacha party? V is equals to A omega. This is what, beta? Cos omega t. Beta, just two beta, just this term, beta. I can say, beta, denominator. V beta A omega is equals to beta cos omega t. Beta, this is what equation number two. Beta, just beta squaring and add both of the equations one and two. Student squaring first and second and add beta. Add bacha party. So you can see bacha, this is a square upon a square omega to the power 4 plus beta z v square a square omega square is equals to 1. Yes. Now beta, woman tell beta, woman Divya beta, tell me, what is the nature of this equation? What is the nature of this equation beta, woman? Tell bacha, what is the nature of equation beta ji? Beta, what is the nature of equation bacha ji? Tell me everyone. Tell beta, what is the nature of equation student? Everyone. Anyone from all of you? Anyone from hello student? Anyone from all of you beta? Please tell bacha. Ara, sir, should I do board or this? Ara beta, do board bacha. Board beta primary ara bacha. आ रहा बेटा बोर्ड प्राइमरी बच्चा, डू बेटा बोर्ड बच्चा, then बच्चा I can say beta come back beta in the month of February बच्चा beta or you are getting time sometime then you can just watch beta sometime little बच्चा but new are beta initially आ रहा बच्चा go and beta focus on board my dear it's a beta highly required beta आ रहा. Okay, anyone answer from all of you? What's the nature of equation, bacha? A square upon A square, beta. This is student acceleration. A square, beta ji. This is A square upon beta A square plus omega to the power 4 plus beta P square A square omega square is equals to 1 beta. Anyone coming from all of you? Write in chat box. Beta, anyone write in chat box, beta? What is the nature of beta graph? Nature of equation, beta? Anyone from all of you? Okay, Arav Sharma, very good, beta. God bless you. Beta, God bless beta, Arav beta. Correct answer, beta. This is what beta you can say ellipse. This is what beta ellipse here. So now beta, just you can draw beta AB graph here. Beta, you can draw beta. This is what acceleration versus beta G. This is V beta. Okay, beta. This is AB graph. This is what beta AV graph here. Right, very good. Now, since I finished here, I can see there are six parameters, which is a repeat telecast of kinematics. Now onwards, beta, I'll discuss some points for numerical. Beta, what I can say some point beta for numerical. After that, beta, I'll start numerical only here. Yes, beta ji. Now, beta, buddy. So now, beta, few points. Beta, few points for numerical. Yes, beta, will help you a lot, beta. Okay. So yes, beta, Physics Point is a platform. Here, students, I'm just always trying to give you best content for entire India, right? So anytime you can watch my lecture anywhere, bacha. So beta, few points, bacha. So this is what beta already I proved. X is equals to beta the A sine omega t. What bacha? X is equals to A sine omega t, where omega t is what, my dear? This is what phase. Beta, usually at this lecture totally dedicated for 11th class student. This is what beta omega t is what, my dear? It's basically phase. It's basically phase beta. What is phase here? It gives us idea about lucky son particle. What's the phase, my dear? It gives it gives us beta z idea about location of particle. Beta, what we can say? Location of particle. Yes, beta. This is beta phase basically. Now, beta, already I see idea. This is next one, beta. I can say beta. This is the first point for numerical beta. Next one, beta. This already I see beta. Omega is what, my dear? This is K upon M. Beta, this is K upon M. Beta, these all which I'm beta giving you beta as a result. They already asked, my dear. Jay beta, you already asked, dear. So please be remember each and every point, my dear. Okay, so beta J ask beta G. Beta just we do a squaring beta both side. What beta G? Omega square into M is equals to K beta. J is to this result already asked. J is to already students. This is asked by J beta. Simple here. The numerical, right? Omega square into K M beta is equals to what beta? You can say K only. Okay, beta more interesting point here for point number three. Beta, if you are at beta, this is you can say beta party. Initially here. Beta, if time is 0, so you can tell beta, what is your phase here? Phase also 0. Beta, this is, you can tell beta, this is the mean position. This is what, my dear? You can tell beta mean position, right? Beta, if we'll finally arrived at what? Left, right extreme beta. This is right extreme. So what is phase here? How much you traveled? This is what you can say, beta, phi is equals to pi by 2. In fact, I'll prove also. I'll prove beta each and everything here. Just stay in the beta live session. Beta, this is what pi by 2 beta z. Now, yeah, finally particles beta at what? You can see mean position beta parties. What is the beta here? Phase angle here. What's the phase beta party here? This is beta. You can see phase is pi beta. But you know beta, this is you wanted to travel entire cycle here. So this is what, my dear? You can see beta. This is what left extreme. This is beta, you can say, my dear, this is a right extreme. This is a beta, you can say, beta the left extreme. Right, bacha buddy? Okay, this is the left extreme, bacha buddy. But finally, beta here will not stop. Beta particle from here to here, beta what? This particle wants to complete one cycle here. So beta, I know this is the final position. So what is beta phase angle beta here? What's the phase angle beta here, my dear? So this is what, my dear. Beta just add pi by 2 here. First beta cycle, this 0 to beta pi by 2. This is the pi by 2 bacha. From here to here beta, this is pi by 2 bacha. Again particle, how much stable beta? Pi by 2. So pi by 2 plus pi by 2 beta. What we can see, this is what? Beta, I can tell you here. This is the point A. This is point B. For understanding bacha, point C and point D bacha. Point A bacha, phase angle pi by 2 beta. Point B bacha, phase angle pi bacha. Point C bacha, this is what beta? Pi plus pi by 2 beta. This is what, my dear? I'm writing here. No, this is the basically, I can say, doubt share by students. Sir, in the classroom, sir, they thrown formula directly. But here, physics point, not possible at all. At physics point, no, in the classroom, beta, maximum student already shared its own experience. Sir, basically in the classroom, they wrote directly formula. But physics point, not possible at all. Not possible at all. Impossible with Chapati. So just stay and beta. I can say everyone watch regularly beta physics one content. Beta, this is what beta I can say. Bacha, this is what, my dear, 2 pi. How beta 2 pi? This is beta 3 pi by 2, my dear. My bad. It's 3 pi by 2. I spoke. Now bacha, this is what we take into 3 pi by 2 plus beta the pi by 2. Then beta what will get? 2 pi. Beta what you will get, bacha party? 2 pi. Okay, bacha. Beta, this is beta what we can say. Beta time beta taken from here to here, bacha. This time is what, my dear? This time is known as, my dear. This is what basically time period. What bacha? This time is what known as, my dear? This is what basically time period. 3 pi. Yes, yes, yes. Very good, Arvind beta. I'm literally beta feeling proud on you, bacha. I'm feeling proud on you, bacha. Here you are doing beta in life, and literally very good, beta. Literally, beta, you are doing very good job. You are here. Beta, take snapshot, students. I wanted to turn the page, my dear. Okay, I hope all of you taken. Yes, beta. Now, beta, just move next here. Beta, what is the next, beta? There is a few beta points because these all things are dedicated only for numerical, bacha ji. So again, you can say, bacha. What, my dear? This is beta 5. This is beta. I can say phase. Yeah, already I said, my dear. This is omega t, right, beta? So phase beta, what I can say for entire time period, beta. The already soon here. This is 2 pi is equals to omega beta, and this is what time is t, beta. Now here I'm writing over here. What's the time period formula which will use beta further here? So this is what, my dear, 2 pi by omega. Time period is what, bacha? 2 pi by omega. Now, beta, omega already, you know everyone here. This is what, my dear? Omega is m upon k. Omega is what, my dear? M upon k, bacha. So you can write, beta, this is what? 2 pi, bacha, party. This is what? Root of m upon beta, root of k. So now onwards, keep in your mind, this is literally, beta, very, very important result, beta. It is what? 2 pi root of beta, what you can say? What I wrote here? Correct, na yaar? Omega I wrote wrongly here. Wrongly beta. My bad beta. This is k upon m bacha. So this is k upon m bacha. So this is what beta can say, m upon k here. So what is the time period bacha party? 2 pi under root bacha m upon k. But I can use here anywhere in SHM bacha party. Okay. Beta, just one more point here. What you can say, you can ask, sir, what is the frequency? You can ask, my dear, what is the beta g? This is what frequency. It's nothing beta. You can say what this is 1 by time period. So you can write beta. This is 1 upon 2 pi beta. This is what beta. You can say this is k upon m. Yes, beta. I give formulas here, and also I explain entire topic. Now onwards, beta ji, I'm going to start practice. Now onwards, beta Z, I'm going to start beta what I can say practice here. Numerical beta. It's more than enough here. Theory. Yes, beta. So now beta take a screenshot beta snapshot so that students I can turn the page. Okay, I hope all of you taken. Yes, beta. Now yeah, have a look at the questions. Bacha ji, beta have a look beta what I can say question bacha. Okay, beta basically yeah, beta which I beta already have taken pi by 2 pi and all. But I'm going to prove beta entire result bacha ji, right? Okay, so beta you can say what's the result here? You can beta think like that. Okay, beta you can say a particle motion beta, a particle motion, if beta particle motion. You can see beta mean positions to what? Half of amplitude. You can see a by 2. You can take beta. This is condition beta, what I'm telling. Beta particle, beta, this is mean position, and this is what? Beta a by 2. We wish to find what is the phase angle traveled by the particle. God bless you for reaction, my dear. We wish to find what is the phase angle traveled by the particle, bacha. Okay, but here I'm considering here. This is what we take. You can take bacha. This is what basically time is equals to 0. This is beta direction of motion of particle. This is sir. I was unable to comment till now. Why beta? Uh, why beta, Subir? Uh, okay, fine. Yes, beta. Now, beta, this is beta mean position. Listen, beta, carefully. It's very good numerical, bacha. Particle beta mean position, and beta particle started beta motion. What you can say t is equals to 0, bacha. This is what a by 2. So, beta, we wish to find what is the phase angle. What is the phase angle, bacha? Okay. So, bacha, party for this condition here. Beta, just go have a look, beta. Solution. Okay, you can take beta. I hope all of you remember. Sir, my parents were outside. Okay, got it, Suvir beta. I'm proud on you, beta. Suvir, got it, my Suvir beta. Got it, my Suvir. Okay, my pride. X is what beta is. This is what we can say a sine beta z omega t. Now, beta, this is a beta. I can say chocolate session started now. So we're beta, chocolate season beta started now onwards, right beta? So we will get chocolate tomorrow, yeah. I can see one chocolate already I have already in advance. Tomorrow beta, I'll give you more chocolate. Yes beta. One more chocolate beta. X beta what? A sine omega t plus 5 beta. Okay, beta I can put beta here. T is beta mentioned here. T is equals to beta what I can say 0. Beta, if you can say a t0 bacha, so what you can say x is equals to a sine phi. I'll go slow bacha, so we then beta you can understand bacha. Yes, you also. Arvind beta, you also bacha. Yes, beta, I'll give you also. Beta x is what beta? Arvind beta, now onwards. Beta, it's a competition. Started beta. Listen beta, Arvind carefully bacha, right? And beta, just answer me beta these questions. X beta what? A sin. Listen here carefully. I'll repeat bacha buddy. X beta A sin omega t. Beta this is beta Subir. Beta already I explained bacha. But now beta onwards. Always you can use bacha. This is what? General equation of SHM my Subir beta. General equation of what my Subir beta? SHM bacha, right? So beta here I beta already put it bacha. T is equals to 0 bacha in this expression. So you can say sir x is equals to a sin phi. I can say beta, you can tell beta x is equals to what my dear? A sin phi. Okay beta, x is what beta? T0. This is a by 2 beta. Already mentioned in the questions my dear. Listen carefully beta. One two question will clear beta for you. X beta what? A by 2 beta for time 0 beta. You can write my dear. This is a by 2 is equals to a bacha ji. This is sine phi. A and a cancel na beta. So I can say sine phi 1 by 2. This implies phi is equals to how much bacha ji? Tell me here. This is pi by 6. Beta what you can say? This is what? Pi by 6. Okay. Now bacha, I'm giving you here. Beta next question here. These all are beta example beta. You can take beta particle motion from what? 0 to beta g. This is a by root 2. Beta, I'll also represent the diagram bacha. Beta, then find bacha ji phase angle. Yes, beta. Find beta the phase angle. Now, beta, you can say what is beta displacement? A by root 2 beta. Beta, this is what? Direction of motion of particle beta towards right, my dear. You can take beta, this time is 0. Beta, you have to find phase angle. You also beta SR01. SR0 में beta, you also बच्चा जी. Anyone beta, answer me beta. What is the beta answer for phase angle for this question? Anyone from all of you beta? Anyone from all of you बच्चा? Anyone from all of you बच्चा? Just answer me बच्चा party. Okay. Okay. You already answered. Oh my God. Sweet. Very good beta. Alsi बच्चा. Alsi बच्चा. So I can answer this question answered by Subi. Just keep in mind everyone for chocolate. Remember how many questions you are beta responding here. Okay beta. Solution here. Let's beta talk about solution. Students, let's beta talk about solution. Okay, बच्चा जी. What beta you can say? X is equals to beta. I'll use beta equation of ऐसे समझ. If anyone didn't get it, then you can beta listen carefully. यार. Definitely will get it, बच्चा. X beta you can say X is what beta? A sine omega t plus phi beta. Just beta you can write here. T is equals to 0 बच्चा. Mention here बच्चा party. Beta you can feed beta this time 0 in this given equation, student. Okay, beta x is what students you can say a sine beta z. This is what 5 bacha. Beta time 0. What is the amplitude, my dear? Right. So you can write this is a by root 2 is equals to a bacha z sine of 5. Right, beta? So always, yeah, all of you welcome at Physics Point. Anytime you can watch the video. Same video, beta, I'll upload. For detailed solution, anytime you can watch, beta. Anytime, beta, you can watch anywhere, bacha. Physics Point for everyone. Physics Point for everyone, bacha. Now, beta, I can say here for this condition. Sir, A and A, beta, what cancel each other, bacha? So what you can write, beta? 1 by root 2 is equals to sine phi. Oh, correct answer. This question rock Subir. Subir answered first this question, my dear. So Subir, tomorrow I'll give beta chocolate. Subir answer for these questions. Subir answered this question firstly from all of you. From all of you, beta. So this is beta answer for this question. Okay, again, I'm giving you more question, beta. Arvind, you can also beta. You will also get chocolate here. You will also get beta chocolate. SR01 beta, I'm not getting reply from your side, bachcha ji. Right? Now, bachcha, let's beta next example, beta ji. Okay. Now, beta, particle motion. Beta, God bless you, my pride. Beta, this is beta, particle motion, beta, I can see 0 to what, beta ji? 0 to, just beta, show your reaction here. You will get chocolate here, Suvi. So, reaction, bachcha, it's highly required, bachcha. 0 to what beta? 0 to what beta ji? Root 3 by 2a. 0 to what beta Subir? This is what beta? I can say SR01 next Arvind. Beta, just all of you are literally lucky to got BK Sir here. Beta, you can go and watch video on YouTube. Beta, how people are teaching here, right? How they are just taking on a disadvantage of online classes here. Now, bacha, what is bacha party? Time beta what? Zero bacha party. You can say bacha. Time bacha, you can say this is what? Remains zero bacha. Time zero bacha. This is root beta. What's the amplitude bacha? Root 3 by 2a. Beta find phase angle bacha. Find bacha ji phase angle. Okay, someone already answered. Oh, already was, sir. Okay. Okay. Very good. Yes. Then you can write a bit in comment section, bacha. Arvind, but I can write in the video channel, video which I uploaded in the section, how I explain the topic, beta. Reality beta, na? Reality beta, spread beta. Reality beta, Arvind spread everywhere. So where is chopper? Correct. I don't know. I have to check. Okay, fine. Bacha, solution here. Beta, this is step one, beta. Solution here. I can say beta you have to use beta equations of beta sim general equation beta for assertion. X is what, my dear? A sine omega t plus phi. Right? Okay. Bacha here beta, I can put bacha. T is equals to 0. What, my dear? T is equals to 0. So you can say bacha X is what beta ji? A sine beta ji. Omega t. Beta this is 0 plus phi beta. So you can say X is equals to A sine phi. Right? X beta the mentioned here for time 0. How much bacha ji? So beta I can put here. Step 2. Time 0 beta, there is X mentioned, my dear. This is root 3 by 2 beta. Beta, you beta same value, my dear. You can replace to x. So this is root 3 by 2a is equals to a beta sine phi. A finish here. So we can write, my dear, sine phi root 3 by 2. This implies phi is what beta? Pi by 3, no? What's answer, Subir, you? Yes, correct, Subir beta. Pi by 3 beta in beta radian, or you can say 60 degree. Beta, I'm really feeling proud on you, Subir beta. Okay, I hope done everyone. I hope done everyone till now. Okay, fine beta. One more last question, bacha party, for this kinds of calculation. Should take snapshot beta. I wanted to turn the page, my dear. I wanted to turn my page. Okay. Okay, Bacha. Now, beta, have a look, beta. Everyone, this is the, I can say last question for this pattern. Hmm. Yes, beta. This is beta. You have to beta find phase angle. Beta, God bless my pride. Subir, find beta ji. This is what phase angle, beta. Figure shown. Beta, what you can see figure shown. Beta, find phase angle, beta ji figure shown. Yes, beta. Stay with this point here. For detailed video, you can watch anywhere, anytime, bacha. So this is what, my dear, dimension here. Let us suppose beta time is what? 0 beta. Particle is at mean position. Beta, what's amplitude bacha party? A. Beta, find the phase angle bacha party. Beta ji, find phase angle. That's is my dear. Okay. Bacha ji, this beta, find beta. Phase angle bacha party. If time 0 beta, particle is here beta. You can see but particles finally beta arrive at mean position बच्चा. Yes बच्चा जी. If particle beta you can see 0 to a, then beta find beta mean angle बच्चा, phase angle 0 to a बच्चा party. Anyone from all of you? Anyone? Okay, okay, got it. Beta got it, yeah, got it. Okay, okay, beta. So now Subir, beta, I'm going to solve beta these questions. Okay, beta, I can see step one बच्चा, right? Beta first I will use an equation which I can say what. Uh, yes. Sabir, you correct, my dear. That's why I'm calling now. You are my pride. You are my pride, Subir, beta. You will create history here. Just stay beta in contact here. Subir, definitely beta will create history here for advance. Uh, zero radian. How beta? Arvind? X beta. This is what beta is sine omega t plus phi beta. You can take beta. T is equals to 0 beta party. So x is what beta g? You can say x is equals to a sine beta g phi. Beta g, just beta. Put beta. X is times 0 beta. What is x beta? In step 2 beta. This is a is equals to a sine phi. Beta a cancel here. So sine phi beta 1 beta. So phi is what beta we can say? Pi by 2 bin hidden with the party, or we can say 90 degree. Till now, topper of the class, I can see for beta who is Suvir only here. Suvir only beta till now, I can say topper of the class here. Okay, bacha. Beta move on next question, bacha party. What bacha I can say? Uh, find time beta. Take snapshot everyone here. Beta, all of you take snapshot, my dear. Everyone here take snapshot, my dear. Okay. Yes, beta. Now, beta, have a look at next questions. Have a look, bacha party. What I can see, this is what next question, bacha party. Okay. beta, this is the literally a terms for numerical only, bacha. This is beta, I can say literally a terms beta what I can say for numerical only, bacha party. Okay, so beta just have a look everyone. Beta write down question with me, bacha. Make note with me, bacha. Which of the following expression, friend, which of the following, which of the following beta expression represents beta represents simple harmonic motion. Simple harmonic motion beta. Yes. Now, Bachaji, this is what I can see beta option first. Means this is a beta. More than one is correct beta. Just keep in your mind, my dear. Okay. Beta, initially I'm considering beta x is equals to a sine beta g. This is omega t plus beta. I can say phi. Right. Beta options number second beta. X is equals to beta b cos of beta omega t plus phi. Third beta g, you can take x is equals to a sine omega t into beta g cos of omega t. Now you have beta last option fourth. Mm, what I can say x is equals to you can take beta a tan what beta g omega t plus phi. A tan beta what? Omega t plus phi. Okay. Subir beta, more than one is correct beta. There is a possibility, my dear. Beta ji, more than one is correct beta. There is a possibility, my dear. Yes, beta ji. Okay, so we beta, what you answered here till now correct, my dear. Okay, beta already if you beta Subir got delay, so I wanted to show you something, my Subir, right? Yes, beta. Where is Subir? Hmm. I explained Subir beta. Beta, I can see notes of this class available in PDF, bacha. Subir bacha, I explained there. There is something. Yes, beta. Hmm. Where, beta? I explained somewhere a student. Yes, beta. This beta. This Subir bacha. Beta, this is harmonic function. Beta ji, this is what, my dear. Everyone listen here. Harmonic function, beta. Beta ji, harmonic function student. Beta say, this is what harmonic function beta. The trigonometric functions of constant amplitude and single frequency is defined as what harmonic function. Beta for SHM, my dear, for SHM beta there are two functions here. A sine phi or beta I can say A sine omega t. The A cos phi beta A cos omega t. Tan, cot, sec, cosec. These all are not harmonic function. These all are not beta harmonic function. For detailed video beta, you can just visit the regular physics point channel, my dear. Okay, beta ji. Now, beta, you can see beta Shubhi. I can see those present in the live session. All of you beta, welcome. Stay blessed, stay happier. Chant Hare Krishna beta. Now, beta, you can see what? Beta, sir, option first is correct. Beta, option second correct beta. Beta, sir, there is a doubt. I can see in option number third. Beta, this is not possible. Beta, good evening, my dear. Good evening, students. You welcome at Physics Beta in live session, my dear. X is what? A sine beta. X beta. No, tan, as I said, my dear. Tan is not possible at all. So there is a little doubt, beta. I can see for this expression, beta z. X is what? A sine omega t into beta what? Cos omega t. What you told, beta? Arvind? No, first, second. Till now, I didn't discuss. Yesterday was my J mains. Okay, how was your paper built, beta? I hope your paper went well, bacha. How was your paper? Chocolate. Yes. Chocolate. Arvind, I'll give you. Don't worry. Okay, beta. Yes, sir. Physics was easy. Yes. True, beta. True, beta. Yesterday, beta, feels literally, beta. I saw beta paper. I can see beta first shift. Right, beta ji? So paper literally are easy. Easy bacha. Okay, you told first. Okay, Arvind. Very good, very good. Then beta, I can say you beta uh, G Sakti. G Sakti, but answer me this question. Means was mine was second shift. Okay, fine, fine. I didn't see beta. I'll beta so don't have beta idea about second shift beta. But now as you told, paper easy means beta easy only beta. Then beta I can say G Sakti answer me beta this question. What's the question beta? Just read once beta. Which of the following expression represent a simple harmonic motion beta? There are options here. Already I marked. X beta is sin omega t. This is true beta. X is b cos omega t plus phi beta. True only. There is a little doubt beta G Sakti I can see for these questions. So what's your opinion beta? Options three. Options three beta belongs to SHM or not? G Sakti. G Sakti beta. Options third is belongs to beta SHM or not? No. Okay, G Shakti beta. I'll beta explain beta. Now beta, I'm going to explaining beta party for beta. I can say options number third. Options number third beta. Beta just beta right as usual beta. Subir equation beta as usual beta. Arvind is at 01. A sine G Shakti beta. A sine omega t. What cos omega t beta? Beta do one thing here. Do one thing beta. Just multiply divide by 2 and 2. X beta, you can say this is a by 2 beta, and this is 2 sine of omega t cos of omega t. I hope all of you remember this is what? Formula of sine 2 theta, my dear. Formula beta what you can say? Sine 2 theta, my dear. So x is what beta you can say? A by 2 sine 2 omega t. This is G Shakti beta belongs to SSM here. Options 3 also correct. Third will not come. I can say Arvind, I explained Betaji. First, second, and third, all are correct, my dear. First, second, and third, beta, all are correct, my dear. G Shakti, beta. At physics one, beta, you will get everything. Don't worry. G Shakti, beta, this is the session. Already I started, beta. I can say 8 o'clock or 8:05, beta, 8:05, 8:05, 10. Beta, I can go and watch, beta, entire syllabus. Beta, every day, beta, I'll come for live for 11th class. Beta, yes, started beta. JEE means sessions 2 beta preparation. So beta, I can say this is the first topic I have taken for beta. I can see JEE main sessions 2 beta, which is oscillation. So beta, I covered each and every bit point. All I explained. In fact, I wrote also as a theory point. So, Jishakti, go and watch beta all lectures. Jishakti, you are basically 11th, 12th class. So maybe you have a places for 12th boards. You will get time better. Just do beta. Explore beta channel. Share with your friends, family. I can say among with your students, like your colleagues, classmates, so that a maximum can get benefit of physics one teaching methodology. Now, बच्चा जी, have a look here. Next, बच्चा जी. बेटा, what's the next question, बच्चा party? Yes, बेटा. Everyone note down बेटा question first here. Or I'm writing बेटा जी शक्ति. Everyone बेटा note down. Sir, both are possible. Beta, I can see Subir A, B, and C. All are correct, my dear. All are correct, my dear. Okay, beta. Have a look, बच्चा जी. Everyone, next question, बच्चा जी. What's the question, student? The displacement student, write questions with me here. Maintain class notes beta with me only with sir. The displacement of a particle, the displacement of a particle in SHM, in SHM, in SHM is, I hope, visual for everyone. Yes, beta. The displacement of a particle in SHM is indicated by equation in the indicated by students equation which is y is equals to beta chain sine students 23 plus pi by 3. right? Where where y is in meter, where y is in student meters. Y is what beta? You can see in meters. The value of time period. The value of beta time period of vibration. What beta? The value of time period of vibrations will weigh. The value of time period of vibrations will weigh. Will be. Okay, in seconds, beta ji. In what beta ji seconds? I'll write option beta also here so that you can answer me easily, my dear. So this is beta options number one, bacha. What you can say this is chain upon pi. Then bacha you can say this is students pi upon one beta. This is options B, my dear. Option C, what you can take so here. Beta, this is you can take beta 2 pi by 10. Students, last options I can say you can take beta this reverse 10 upon 2 pi. The amplitude is 10. Okay, units, angular frequency is 20 radians per second. Okay, and the initial phase is what? I by 4 radians. Okay, but I wanted time, my dear. Arvind, I wanted time, bacha. I wanted bacha the time period. Really, I'm very happy here. Really, bacha, I'm very happy to see each and everyone in the live session here. In the live session. Yes, basically, beta, how all of you responding here. Hats off. Okay, I got Subir answer, bacha. Literally, all of you liking, bacha. Please, beta, show your enthusiasm, motivation throughout reaction, bacha. React more, bacha, and spread me about with your friends, family, and everywhere, students. Okay, have a look, students. I can see solution of this question, beta. Students, have a look, beta. I can say this is what beta solution. Beta, just simple here. I can see in step one beta. You can write, my dear. Y is equals to 10, which are the sign. This is what 20t plus 5 by 3. Beta, you can just beta equate this equation, beta. Just beta, I can say compare. Beta Z, compare beta above equation, above equation beta from what beta I can say general equation of SHM. General equation of beta SHM here. Right. Okay. So I hope all of you remember what is the general equation of SHM? A sine omega t plus 5. Beta just you can equate bacha ji in step 2 beta you can write my dear everything. Step 2 beta, you can write here everything, bacha. So this is what you can write beta. This is what beta from above equations. A is equals to 10 bacha ji. Omega beta, you can write 20. 5 beta, what you can say? This is what pi by 3. We wish to find beta time period. So what is beta? In step 3 beta, you can use beta as a result. Right beta? I hope all of you remember. What's the time period, beta? T is equals to 2 pi by omega. So this is what 2 pi by omega is what already you got beta. So I can say equations number one. You can say my dear equations number two beta g. This is what beta. So what you can say beta. This is what 20 here. So A will get this is pi by 10 seconds. Any option is there beta? Anyone from all of you? Which option beta? Pi by 10 seconds? Anyone from all of you? Okay. Okay, fine. Arvind, you answered this question. Very good. Hats off, beta. Okay. 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 5 by 10. Yes. Yes. Very good, beta. Sir, I took a science. Okay. It's fine. It's fine, beta. Sure, beta. Don't worry. Beta, option Bombay is correct answer with Charity. Option beta, what? Bombay is the correct answer. You did B options. Yes, yes, beta. Beta, I forget here. I forget, beta. Arvind. Correct, my dear. Okay, just beta. Have a look at next questions, my dear. Beta, take snapshot, beta Z. Take beta snapshot here. Okay, beta take snapshot beta for entire solution. You can watch a detailed video anywhere, anytime bacha party. Right? It's a highly required beta and highly helpful for each and every students pan India beta. All of you welcome at Physics Point. Hare Krishna, my dear. Aditya Krishna, you welcome beta at Physics Point. Yes, bacha ji. Have a beta next questions here. So, beta, this is next questions, my dear. Literally, beta, all of you liking your live session of this one, bacha. Please, bacha, just share enthusiasm, beta. I can see by the help of beta reactions, like the video, spread me with your friends, family, and classmate as well. Okay, beta, have a look, beta, next questions. The equation, students, the equation of simple harmonic motion. The equation of it a simple harmonic motion. Sir, please advance question. Okay. Yes, yes, beta, give me chance. We beta. No, what happened? In live session, nobody in front of me. Because I know beta about your finger. I did seven lengthy multiple correct questions only, sir. Okay, very good. Very good, beta. Aditya Krishna, beta. I'm proud on you, bacha. So live this session, bacha, I can say Suvir for everyone. Each and everyone, bacha, I can say, bacha, get benefit here. So slowly, beta, Suvir. Slowly, beta. Yes, beta. The equation of SSM, bacha, is yes, beta. Y is equals to beta. Just practice more, beta. Practice more, beta. Practice makes man perfect, beta. Aditya Krishna. No, it's fine. It's fine, my dear. My pride, beta. Suvir. Y is what, beta? You can take, beta. This is what I'll say, beta. X here. So X you can take, beta. This is 0.34. Beta. This is you can take, beta, cos function. Student beta. This is what 300t plus beta the 0.74 beta. This is the equation of beta SHM mentioned here. X is equals to 0.34 cos of 300t plus beta 0.07, where X and beta t are in what beta I can say mm second बच्चा बच्चा जी here बच्चा you can take beta x beta in बच्चा and time बच्चा you know everywhere remains as seconds only बच्चा the frequency of the motion you have to find students find the frequency of the motion find the frequency of motion in beta जी hertz in beta जी hertz. Okay, sir, do you have videos on mechanical properties of solids, sir? Mechanical properties of solids, my dear. No, beta. Beta, just now, beta, I started beta. So I uploaded with lecture on statics only, fluid static bacha. But if you demanding bacha, so once beta I'll finish oscillation bacha in the live class I'll teach beta I can see mechanical properties of solids bacha. Right, my dear? Okay. Or I can do beta one thing. Just beta, just remind me on Sunday. On Sunday, beta, I'll become with analysis. Or we can beta, I can say J main. Beta first attempt. What's the analysis? Beta, there I'll take 4 or 5 hour class for mechanical properties of solids. Right, beta? Yes, this is the possible. I can do beta. I can do bacha. Just remind me, my dear. What's your name, bacha? Write your name so that beta I'll remember. Or just mention your name beta in comment box as well, bacha ji. I'm writing beta the options here. So beta I can take options beta ji. Options Suvir beta 3000 beta 1500 beta upon 2 pi beta, this is 0.74 upon beta 2 pi. What's the possibility, Subir? I can make here. Just you can take bacha. This is 3000 upon pi bacha. Yes, bacha ji. Okay. Okay. Arvind also answered. Subir also answered. Okay. Fine, bacha. So, beta, this is the questions here, right? I don't know, bacha. What's the questions? Just wait here. I'm going to solve, my dear, these questions here. Okay, Bacha, this is step one here. You know, all everyone, because they're always going ahead for the solution, step by step, Bacha. So, beta, this is step one, beta. You can write, beta, given equations. Beta, you have to first write, my dear, given equation. Student, you have to first write, beta, the given equation. X is equals to 0.34 students cos of 300t plus beta g 0.74, right? Beta equate beta this equation from general equation of beta g SHM. What beta you can say? This is a cos beta omega t plus beta what? You can say kx. Beta what we can say? Omega t plus kx. We can also say beta but in both of the formats. Okay, then beta what you can say right here? Just beta do comparison here. A is what बचा जी 0.34. Omega beta what you can say this is 300. Sir, okay sir, my name is Arnab. Arnab, from where? Thank you for your time, sir. I'll come Sunday. Bye, sir. Good night. Jai Sri Ram. Beta Jai Sri Ram. Omega beta. This is what? Beta ji 300. Okay. Omega beta what? This is bacha party. You can see 300 bacha. So beta this is omega na? Yes, bacha. I can see omega. Hmm. So beta we used to find beta what? Angular frequency is simple here. Beta step 3 beta. This beta note down here. Beta what you can see bacha? This condition. Hmm. Beta g. This is omega beta. Can you use here? Omega is what beta? 2 pi f. So beta we used to find frequency here. So beta what you can say frequency bacha? This is omega upon 2 pi r. So what's omega here? This is 300 upon beta g 2 pi r. So beta this is what? You can say 150 upon pi in hertz here. Any option is there? 150 upon pi, or you can say 300 upon 2 pi. 150 upon pi, there is no option at all. 150 upon pi, there is no option at all. So just I'm just making option here. 150 upon pi. 150 upon pi. Okay, sir, my answer was correct. Okay, I message. When beta, when Subir? I didn't see bacha. I didn't see bacha. Okay, I also told. Okay, fine, fine, very good bacha buddy, very good bacha buddy. I can say bacha. This is what option beta Bombay. Very good, but both of you, I'll take. Okay, sweet chocolate. Confirm. Beta chocolate confirm. Okay, before options. Okay, okay, okay. Beta confirm beta chocolate, my dear. Beta confirm beta chocolate, my dear. Okay, beta. Just beta, have a look at this is beta last question for beta today class. Right, my dear? Okay. Bacha ji, the distance students, beta note my questions with me, everyone. The beta ji, distance covered. Distance covered by a particle executing SHM. Particle executing SHM in one time period. In beta one time period is equal to beta. So this is options here. Beta you can see four times the amplitude. FOUR. Four times of amplitude. Okay, beta. Next here you can say two times of amplitude. This is beta. You can see two times of amplitude. Beta options third beta, one time of amplitude, one time of beta g amplitude. Beta, God bless you for reaction, my dear. Beta जी last option बच्चा eight times, eight times of amplitude. Yes, beta. Just answering it, everyone here. Beta, what question is the distance covered by a particle executing as a distance they asked. Beta, they asked what distance here. Okay, option C. Okay, okay. I can say Suvir option C. I can say Arvind option C. One more students I can say gaming. I don't know who is this. He also answered options A. Okay, sir, options A. Okay, options A. Okay, okay. Very good here, very good. Options A, I'm getting more beta. Okay, options A. Options A. Okay, beta. Just give me a second, beta. Mhm. Sorry. Beta, no, sorry, beta. I don't have beta any videos on mechanical properties of solids, beta, right? Beta, as I said, yeah, I'll come on Sunday, beta, to live, yeah, to just teach mechanical properties of solids, yeah. Yes, beta. Have a look solution here. Then, beta, I'll just declare answer, beta, for this question, beta party. What's the question, beta party? Just listen here, everyone carefully. Beta, two, beta, one horizontal line. Right, my dear? Yes, yes, Arvind, I got it. Beta, I saw your beta options. I saw beta your option in chat. So, bacha, beta, just give me a second, bacha. I'll explain, bacha. If your answer correct, then I'll say, beta, your answer correct only. Beta, you can say, this is my dear, you are at mean position. Dear, this is what you are at mean position. Beta, you will go here, I can see what? Right extreme, bacha. How much you will travel here? A only. Right. Bacha now, beta, you will beta coming back, beta. This is remains A only, beta. Right. Beta, here to here, beta. Again we'll go here. So this is remains A only, beta. Distance they're asking here. Beta, what they're asking, beta, about it? Distance here. Just be careful, beta. So this is A, beta. This is A, beta. This is one more time, beta. This is what? You can see, beta, left extreme here. So here to beta. Here, this is what? One time period here. So how much here? Amplitude. What's the amplitude, beta, about it? One, two, three, four, beta. Four times of amplitude. Options A is correct only. Options A is correct only. Options A is correct, bacha. Yes, beta. Yes, bacha. Beta, options A. Very good, yeah. Yes, correct, beta. Correct, correct, correct. Arvind, your answer correct, beta. I got it. I remember, beta. Arvind, you answered yes, yes, yes. The sweet previously you answered, beta, like some different option. Okay, fine, fine, fine. Very good. Very good, Bachcha Party. Literally, I'm very happy to see each and everyone in beta live session here. So, because beta, I'm bonded with beta timeline here. I'm very happy beta to see all of you in the live session, Bachcha. But literally, you can watch beta anytime, entire. Yes, yes, tomorrow. Tomorrow, beta, Arvind, you will get chocolates. Definitely, bacha. So, all the best, everyone. Just watch, beta. I can say, beta, physics point regularly, bacha. Spread me with your friends, family, and classmate, bacha, party so that maximum student can get benefit, bacha. Now, beta, I'm going to just stop this live session, bacha. Hare Krishna, everyone.